So there's different terms here for parts of a polynomial. Coefficient, exponent, constant, variable, and then terms, and then degrees. So the first one we're going to talk about is coefficient. So coefficient is pointing to a 4, and it's pointing to a 5. What's special about those numbers compared to everything else? They're numbers, right? First of all, what's special about them?
They have variable behind them.
They're stuck to a variable. They're stuck to a variable. So that's why it's not pointed at 2. You see 2 it's not pointed at 2? Because 2 doesn't have a variable by it, right? That's the next thing, right? So what is 2? 2 is a constant. Okay, it's a constant because it never changes. It doesn't have a variable with it. If it doesn't have a variable with it, things that have variables vary. They change, right? Constants don't. They remain the same. Exponent, you guys know exponent, little number is power. Okay, so down here we have 3 terms. This is the first term. This is the second term. This is the third term. It's got 3 terms. It's called the trinomial. Okay, we'll get down at the bottom, we'll talk about trinomials, but the first term is 4x cubed. That's also the leading term. It's the leading term because it has what we call the degree. The degree for this guy is 3 because it's the highest power, right? So it doesn't matter. This guy could have been over here somewhere. Doesn't matter where it's located. If it has the highest power, it's the leading term. Because it has the degree. Okay. So down at the bottom, we have a matching. We have some matching with some terms. Okay, so we have some 1 goes in each box. So I'm going to label them A, B, C, D, E, F, and G. So I don't have to write the whole thing in there. You can if you want, but. So one of which goes in any, 1 letter is going to go in every box. Okay. So if you look at the first 2, they both have the word coefficient in them. This one has a coefficient, and this one has a coefficient. But the second one is the leading coefficient. Okay. So which one's going to be the coefficient? Just the coefficient. Bennett, you know? F. F. Good. The 5, if you look at negative 5, if you look at the negative 5, that's a coefficient. The negative 5 front of the x, yeah. So F would be there. Now this one is the leading coefficient. We didn't choose F for leading coefficient because the negative 5 wasn't the leading term. So the coefficient in terms of the leading term, which one is that going to be? Let me cross this one out because we're done with it. F we're done with. Yeah, Julio. Go ahead. Well, yeah, why is that one the leading coefficient? It's the leading term, right? So the 7 here and the 7 there, that's the leading term. So E goes there. Good. Constant. The constant. Constant would be, yeah, letter, where is it? G, yes. The 9 plus 9 is just by itself, right? So that's going to be G. Good. Cross that one out. Monomial. Mono means how many? 1. And that's the one, right? B is the one that has 1 term. B. Bi means 2. So just say it out. Say it out loud. A. Good. Let me cross these out. B's gone. A's gone. Tri means 3. D. C has 4 terms, which is a polynomial, many. Good. Okay. Good. Okay. So now open up and look at number 1. This should look familiar. We've seen problems like this. You saw a problem like this on the tests that some of you just finished or are still working on, right? What do we need to do? Take a quick guess as to what we need to do, and you'll probably be right. Yeah, Zach? Distribute, absolutely, yeah. Distribute, multiplication, right? So I know what I need. What do I need to distribute here? The -1, right? So I distribute that there and there, right? So that's going to change the sign. So it's going to be positive 2x squared plus 4x minus 7, right? No more parentheses. Now, what about the first set of parentheses? How do I get rid of those? Distribute the +1. We're still distributing, but the +1. Now, what's this thing about distributing a +1 though? It stays the same. Yeah. So it stays the same. Since this is your notes, I'll do it, but on, most times you don't need to do this because it's a +1. Good. Distribution is done. Good. What do you think I'm going to do next? You guys are right. Combine like terms. These guys have x squareds. These guys have x's. And these guys have our constants. Right? They're just constants. So we combine the reds, combine the blues, combine the yellows. Do the reds first because that's the highest power. So when I combine the reds, what do I get? 5, not 5, not negative, close. Yeah, look at, so you got a -3, and when you combine, you add, right? +2, it's going to be a -1x squared. What about the blues? Good, -5x. And then the yellows? -2. No more. I can't combine anymore. They're not like terms anymore. Done. That's our answer. It's simplified. Yeah, simplify as far as you can, and then you call it a day. Right? Everything's done. No more parentheses, no more exponents, no more multiplication, division, addition, subtraction. I did all that. I'm done. This guy here. What do you think I'm going to do here? Distribute. You're right. 100% right. Distribute the x squared to these guys here. Now, anytime I'm distributing a power, right, x to something, this is what I do. I write it a little differently. I write the power in the front, so whatever I'm distributing, and I write what I'm distributing to here. Because sometimes it's hard to see in your head, what is this going to be? What is -10 x squared times x squared?
-10 x4.
There you go. It's going to be -10 because this is a 1 in front, right? And it's not going to be x squared. It's going to be x to the 4th because you're multiplying powers. So when you multiply powers, they become more. Divide powers, they become less. And then this guy is just going to be 1x squared. Now look to the inside. Once I filled in the inside, is there anything that combine like terms? Nope. So I just write the big power first, smaller power second. Done. Simplified it as far as I can go. Number 3, what do you think I'm going to do here? Distribute, right? But what's true about the thing I distribute? There's 2 terms, right? There's 2 terms I distribute, right? I've distributed -1s before, but you're not distributing -1s. You're distributing 3x minus 1s. So we've done this before, and I just kind of did this here. I'm going to set up a multiplication table. I'll tell you why in a second. Multiplication table keeps everything organized, right? If you have too many of these things, here, kind of becomes a lot. So I keep things organized, and it makes it visual too. So on one side, this guy has 2 terms, right? This guy has 2 terms. 2 terms, right? So I need a side with 2 terms. 3x and a -1. And then this one has 3 terms. It's a trinomial. So it's got to have three sides. So this one is 3x squared plus 4x plus 6. We've did this before. We've done multiply like this before. So what I do is I multiply coefficient times coefficient. 3 times 3, that makes 9. And then it's going to be x to the what power? Third power. Because I'm multiplying. If you multiply powers, you add them. You end up adding them. So I got a 4 times a 3, which is a positive 12. And then each of them has x. So x to the power times x first power times x to the first power is x to the second power. And then I have 6 times 3, which is 18, just x to the first power. Because 6 doesn't have a power, doesn't have an x. So now I do it to the second row. The second row is negative 3x squared, negative 4x, and negative 6. Okay. Multiplication is done. What do we do after multiplication? Combine like terms. Yep. Combine like terms. These guys are like terms. These guys are like terms. The two that I didn't circle aren't like terms. So they don't combine with anything. So when I combine the reds, I get 9x squared plus 14x with the blues. And then the negative 6 is a lone wolf, just like the 9x cubed was. So it just gets written down like that. So we call this descending order. The answer is in what we call descending order. If I descend, what does that mean? Come down, right? Yeah, come down or go smaller and smaller. Like if you're in an elevator on the top floor and you need to get down to the bottom floor, you're descending, right? Ascending means you're going up. Descending means I'm coming down. In our terms, it means I'm going down in power. You start with a high power, lower power, lowest power, and then this one doesn't have a power. Okay. All right, so try number 4 on your own. Give number 4 a shot. Same type of problem. Give that one a shot. I'll give you about 5-6 minutes to do that one, and then we'll do it together. Try it on your own. If you get it wrong, big deal. It's just your notes. But try it on your own and see if you can do it right. Okay, so I'm multiplying both of these trinomials times each other. How do I know it's multiplication? How do I know I'm multiplying these trinomials times each other? Yeah, in between, there's no plus or minus, right? If there was a plus in the middle here or a minus in the middle, you would do like we did in number 1. But if there's nothing in between there, that means multiplication. So we got a trinomial times a trinomial. So I set up 3 times 3, a 3 by 3, 3 by 3 box. Now, how about this? Can I do this? Can I move these guys? Switch spots. So can I switch like this? Can I switch these guys with these guys spots? Can I flip flop those? Yes. The answer is yeah, because they're both the same size. They're both trinomials and it's multiplication. Multiplication order does not matter. All right, so now let's see. This is going to be positive 4, right? X squared times x squared makes x to the 4th power. This is going to be negative 12 x cubed, because x to the 2nd times x is x cubed. 16x squared. 7x to the 3rd power. Negative 21x squared. 28x. 3x squared, bottom row, negative 9x, and a positive 12. Combine like terms. This one, we're going to have more like terms to combine because it was a bigger multiplication problem. So combine all the cubes, x cubed, combine all the x squareds, and then the last thing I'm going to do is combine the x's by themselves. Okay. So the 4x to the 4th power, there's nothing to combine that with. So that just starts out in front. The next one is cubed, the 2 reds. The 2 reds, I combine those and I get 5x cubed. The greens, I combine the greens and I get negative, is it, or not the greens, the blues, yeah. To combine the blues, I get negative 2 x squared. And then the yellows, the last one is the combine is the yellows, positive 19. And then the last one is just a lone wolf, 12. Okay. Not too bad. Last one and last one on the notes, this guy here. So this guy here, you're really going to need to use PEMDAS and use it correctly, because if you don't, it's going to go, you're going to get wacky answers. Okay, so which one are we going to do first? Exponents, right? Exponents. Yeah, a lot of people say distribute. No, you're down here. You're the M's. We're still in the E's. We got to do exponents first. So exponent is this guy here, right? So doesn't that mean times itself? Okay, so I'm going to do that right now over here. I'm going to set up a 2 by 2. X plus 4, x plus 4. So I got x squared plus 4x plus 4x plus 16, right? I have some like terms in there. So I'm going to change this to x squared plus 8x when I combine the reds plus 16. This stuff here just comes down because I haven't used it yet. Okay. Now the exponents in that parentheses are gone. Now what do I do next? Distributive property. Now I can do M. Now I can move down to M. Good. So it's going to be negative 4x minus 16. Everything else just moves down that I didn't do anything with. Combine like terms. I have a positive 8x, negative 4x, and then the constants, I have a 16, a negative 16, and a 6. So is that 4x? The reds would be 4x. The blues, just 6, right? Positive 6, because the 16s cancel each other out. Okay. There's one other type of problem that I want you to look at because it's a little different. So you're going to do it. I'm going to pass around the tape. You're going to tape your, you're going to tape this into the next open. And then you're going to we're going to do a problem right underneath that. So it'll be example number 6. Yeah, go for it. Okay, so right underneath it, we're going to do example number 6 because there's one type of problem that we haven't talked about that I want you to have in your notes. Okay, so tapes comes around. Which one? The quiz? What is that? What is it? Can you? I can't read it. Can you read what the? So what does it say? What does it say before test on Friday? Quadratics. So it's assignment. If it's an assignment, you got to do it this way. You got to turn it in this way. Nope. We don't attach our assignments in there. We scan and upload the assignments. If it's an assignment, scan and upload it. What's that? I think that's where we're at. Okay, here we go. Let me give you this problem. Okay, write that down. What's that? We'll talk about it. Yeah. Just write it down first, and then we'll go over. So what's different about this one? Looks like the problem I just gave you. So why did I say it was different? Yeah, exactly. Yeah, it has a 2 in the front, right? The last one didn't have that 2 in the front. It had a 1 in front that we didn't care about because it was a 1. Is that going to change anything we do? So here we go. This is the biggest mistake. This is the biggest thing I see. Oh, distribute the 2. Can we do that? Good. I'm surprised. Most students say, yeah, do that. We can't. Why not? Exactly. We can't go here unless we pass E, right? E means exponents, which you guys just said. So what we're going to do is we're going to take care of this guy over here. I'm going to cut a piece out, and I'm going to do it over here. So over here, it's x minus 5 times x minus 5. So that's x squared minus 5x minus another 5x plus 25. combine some like terms over here. Now I'm going to replace it. I'm going to replace that in here. So everything's going to stay the same. The only difference is I'm going to write it like this. Because I needed to do that to take care of exponents first. So that's what I do first. Okay. So let me write another arrow. And then once I come out here, I come in here. Okay. So now there are no more exponents. There's no more 2 out there. So I'm done with exponents. Now I can move to multiplication. So multiplication means distributive property. So now I can distribute the 2 here and the -2 here. So this would be 2x squared. 2 times -10 is -20x plus 50. And then the -2 would be -2x plus 10. And then the -5 out there that we haven't used yet. Okay, now let's start to combine. Now we're down to A and S, addition, subtraction. So I have an X here and an X there. And then I have a constant here, constant there, and another constant out there. Two x squared minus 22x plus 45. Okay. I want you, now we did that one together. I want you to try one on your own now. Okay. I want you to try one on your own. This will be example number 7. This is the last thing we're putting here with you. $55. Yeah, it'd be 55. Because the greens, 2 of them are positive. 50 plus 10 is 60. And then -5 is 55. Where? Yeah, that's what you guys just said. It was wrong, right? Okay, 55 I think is correct. All right. Okay, here we go. Last one for you guys. This one you guys are going to do on your own. Simplify as far as you can. When it says simplify as far as you can, it means use PEMDAS as far as you can. Okay, so I'll give you about 5 minutes to do this one, and then we'll go over it, and then we'll be done. When you're done, look up here. Did I do something wrong? What did I do? Oh, wait. Yep. That should be 8. So that should be 4. Okay. Now look at it. Good. All right. Okay. Tomorrow we'll do some practice. So tomorrow we'll do some practice on your own, and that's about it.